module. So in this tutorial, I'm going to explain the environment on which we will implement our artificial intelligence, and that will contain, of course, the car that we will train to drive itself and to avoid obstacles, and on which we will draw some roads and some blocks for our car to navigate around them. So we will later build this artificial intelligence to train this car to drive on the road, without crossing the limit and avoiding some obstacles that we will put inside the road. So this is a pretty exciting challenge, and actually there are two separate files, as you can see. There is the AI Python file, that's our artificial intelligence that will do all the training to train the car how to self-drive, and we have the map.py file, that is the code that makes all this environment. So here is that code, that's actually 200 lines of code, a little more. So this code is not typically related to AI. It is just the code to make the environment, to make the map. So I'm going to go through each of the sections one by one to explain, but we're not going to implement this code line by line from scratch because we want to focus on artificial intelligence. But let's still go through the sections one by one to understand what's happening. So first, we import the essential libraries. That's for any code. We need some libraries to perform some tasks more efficiently. Then we import all the Kivy packages. So that's not very important because this is all specific to Kivy. We're using Kivy to make the map, and so we're importing a lot of classes and objects to be able to make this map and add some tools in the map. All right, then this line is important. This line is AI related because basically this is where we import our brain, the brain of the car, which will be an object of this DQN class, and the DQN class is our artificial intelligence itself. You will see we will implement the DQN class in the following tutorials, and as you might have guessed, DQN stands for Deep Q Networks. So we will implement a Deep Q learning network, and then once it's ready, we will be importing it here with this line from the AI. And the AI is, of course, our AI Python file. All right, so can't wait to implement this. This is going to be quite a journey, but you will see this is going to be very exciting, because thanks to the AI, the car will be able to drive itself. All right, and now, before I move on to the next sections, we have to explain how we will train this car. I'm not going to explain the neural network right now, but I'm going to explain the idea of how we're going to train the car to drive itself and to avoid obstacles. So in real life, if you want to train a real car to avoid some walls or some obstacles, well, what would you do? You would definitely not take real walls or real big obstacles and smash your car onto them. That would cost you a lot of money. Instead, a more intelligent idea would be to punish your car not when it smashes a wall or an obstacle, but when it goes onto some sand. So it's like you have a field. This field has some roads on which the car has to stay, and the roads are delimited by some sand. And each time the car goes onto the sand, it's like it's going onto an obstacle, because once the car goes into some sand, it will be slowed down, and we will make sure that the car is penalized, is punished for that. And that is one essential point of our artificial intelligence. The bad reward comes whenever the car goes onto some sand and is slowed down. All right, and therefore, here I'm introducing last x and last y, which are the coordinates of the last point in memory when we draw some sand on the map. All right, and then we get our artificial intelligence, which we call brain, and that contains our neural network, and we will call it brain because this is actually the brain of the car, and that contains our neural network. All right, so in this line of code, as you can see, I'm creating an object of the DQN class. I will remind what classes and objects are, but brain is the object, DQN is the class, and 5, 3, and 0.9 are the inputs of the class. So that's very simple. 5 corresponds to the states that are encoded vectors of 5 dimensions. We will see what they are, perfectly describing what's happening in the environment on the map. Then 3 is the number of actions. There will be 3 possible actions: go left, go straight, or go right. And 0.9 is the gamma parameter in the deep Q learning algorithm. All right, and then we have the action to rotation. So action to rotation is a vector of 3 elements, 0, 20, and minus 20. And so we have to do this because the actions are encoded by 3 numbers, 0, 1, and 2. and that corresponds to the indexes of this action to rotation vector. So for example, if the action that is selected at time t is 0, well, 0 corresponds to the index of this action to rotation vector, and the value of index 0 is 0, and therefore we will go straight. Then, if the action selected is 1, well, 1 corresponds to the index of this action to rotation vector, and the value of this vector that has index 1 is 20. So 20 corresponds to a rotation of 20 degrees, and that means the car will go 20 degrees to the right. And then, if the action selected is 2, well, 2 corresponds to the index 2 of this action to rotation vector, and therefore the car will do a rotation of minus 20 degrees, and therefore it will go to the left. Alright, then we introduce the last reward variable, because at each state we will be getting the last reward. So remember, if the car doesn't go onto some sand, then the reward will be positive, and if the car goes onto some sand, well, it will get a bad reward. And at each time, this variable will contain this reward that it gets at each time t. And then we initialize the scores, which is a vector that will contain the rewards, not all of them, but the rewards onto a sliding window, so that we can make a curve of the mean score of the rewards with respect to time. Alright, then in this code section we initialize the map. So we initialize, for example, the send variable. So that's important. The send variable is actually going to be an array in which the cells will be the pixels of the map. And in each cell, we will have a 1 if there is some sand and a 0 if there is no sand. At the beginning, we will not be drawing anything, so there will be no sand at all, and therefore all the cells of the sand array will have a 0, so there will be zeros everywhere. And as soon as we draw some sand, well, the cells on which we draw the sand will get a 1. And we initialize the arrays with all the zeros right here. Sand equals np zeros. Then we have this important thing, which is the goal. So the goal is a point in the map which we will train the car to reach. So it's like a destination. So what is this goal going to be? Well, this is going to be the upper left corner of the map. So we will train the car to go to the upper left corner of the map, and then once it reaches the upper left corner of the map, then we will train it to go to the bottom right corner of the map. So we can imagine the following scenario. The upper left corner of the map is the airport of a city, and the bottom right corner of the map is the downtown of the city, and we will train a taxi or Uber to do some round trips between the airport and the downtown. And of course we will make the task difficult to this taxi by drawing some more and more difficult roads and adding more and more obstacles on the street to see if the taxi can still manage to go from the airport to downtown. So this is going to be fun, and so that's why here I'm setting the coordinates of the first goal, that is the airport, which is at the upper left of the screen. So the map will be like a square like this, and the coordinates of the origin, that is the coordinate 0, 0, is right here. And then larger is this distance here, so the coordinates 20 and larger minus 20 will therefore be right here, the upper left corner of the map. And why did I choose 20 and not 0? Well, that's because we want to train the car not to rush into the walls. We want to train it to avoid the walls as well. And therefore the goal must not be 0 because we don't want the car to touch the wall. We want to touch the goal, so we have to put it right here. And then I'm just introducing the last distance variable, which just gives the current distance from the car to the goal, and that I'm initializing to 0. Alright, and now time to make the car and the game. So we're going to make two classes, one class for the car and one class for the game. And inside these classes, we will already make some connections with our AI. So we'll do that in the next tutorial, and until then, enjoy AI.